Higher threshold than rare earth technology, China reveals new ace. The 6-inch thin film lithium niobate photonic chip wafer has gone offline, and a new track has emerged, photonic chips. Recently, a trial production line for thin film, lithium niobate photonic chip wafers was officially launched in Wuxi. This seemingly inconspicuous wafer marks China's breakthrough in the field of optoelectronic integration. In the era of electronic chips, information is transmitted electronically, and the smaller the process, the more severe the heat generation, and the higher the cost, the lower the yield. Processes below 5 nanometers are already approaching the physical limit, which is precisely why the United States is able to accurately constrain China. Equipment, software, and materials can all become toolkits that constrain China, but photonic chips are not electrons. They run light. Signal transmission is close to the speed of light. Heat generation is almost negligible. Energy consumption is extremely low, and bandwidth is unimaginably large. This not only paves the way for the next generation of communication, AI computing, and quantum computing, but also signifies a fundamental upgrade in information hardware technology. Lithium niobate materials from China. Compared to silicon-based photonics and InP devices, lithium niobate has stronger performance advantages in modulation bandwidth, electro-optical conversion efficiency, and signal integrity. However, the process difficulty of lithium niobate wafers is extremely high and has always been regarded as the ceiling of industrialization. There were many countries in the past that could produce samples, but currently only China can make it into a 6-inch wafer and put it into mass production. As the foundation of the new generation of computing architecture, once photonic chips can be manufactured on a large scale, it will not only be a technological breakthrough, but also a rule change. The essence of technology blockade is to prevent latecomer countries from finding an overtaking path, but photonic chips happen to not break through and catching up, but to bypass the original track and start anew. With a modulation bandwidth of 110 GHz and insertion loss below 3.5 decibels, it means that China is competing with top companies such as Hyperlight and Sicantum in the United States. In comparison, one can already stand on the technical contour line. This is not a matter of meeting American standards, but rather the possibility of choosing one's own path and forming independent standards. This 6-inch wafer is not isolated. It links China's expertise in rare earth extraction, laser technology, chip packaging, and chip racks, accumulation in multiple fields such as structural design and optical communication systems. As an ecosystem gradually closes, the US licensing list will become a paper tiger. Even if in the future, American AI companies and large model companies also need to use photon architecture, China will become the only source of certain key components. In the past, rare earths were China's trump card, but now it seems that they are just a hedge against the resource layer. The real technical trump card is no longer to defend, but to play. Electronic chips are a battle of pursuit, while photonic chips may open up a new chapter. When China has a solution in hand for both the underlying materials and core processes, the technology card in the trade war loses its one-way advantage.